can we go to the toy store? Dad.
We are all familiar with sound waves,
Come on.
and we've had experiences with light waves. And everybody seems to love water waves. But seismic waves, I could do without those.
And as different as all these waves seem to be, at their core, they're really all the same.
And our understanding of what waves do and how to harness their power has literally changed the world in countless ways.
So today, we dive into the wondrous world of waves. The first thing that all waves have in common is that they move energy from one place to another.
And energy is just the ability to do work or cause change. If something has energy, it can move things, like this bowling ball. And light waves carry enough energy to cause changes to your skin cells. And sound waves, they'll shake your eardrums. And water waves are so strong they can lift 100 humans 10 feet in the air with no problem at all. And seismic waves, well, they can move cities.
And another thing all waves have in common, they all have a source. They have to come from somewhere.
So let's make some waves of our own. Now, water waves can come from a variety of places, including people. But most commonly, water waves come from wind. Sound waves come from any type of vibrations. Light waves, in nature, they come from nuclear fusion in stars. And seismic waves come from motion along faults. They're earthquakes.
Now, I've tried to think of ways to teach you this that are entertaining, but the only way I can really think of doing it is I'm gonna have to dance. I'm sorry, that wasn't supposed to be a joke. That's actually how the three types of waves travel. I'm just sorry I had to see it.
You know, I guess I could show you with giant slinkies as well, so let's try this. This is a longitudinal wave. It travels by compressing and expanding the medium it's traveling through. As my hand moves back and forth, so does each part of the slinky, parallel to the direction it's traveling. And this next one is a transverse wave. Here, my hand goes up and down, but the wave goes forward, and every part of the spring is just going up and down too. And finally, the surface wave, a combination of transverse and longitudinal waves. Watch as my hand is actually going in a circle, and so is any given point on this spring. And I keep using that term medium, and here's what it is. Natalie, take it away.
A medium is a substance a wave travels through. It could be solid, liquid, or gas.
And while we're on the topic of mediums, I'm gonna wrap up this video by asking you 3 questions about waves. Number 1, what is the only type of wave that can travel through all 3 mediums, solid, liquids, and gases?
Well, it's not a light wave. They don't need mediums to travel through. They go through space, which makes them incredibly useful. And it's not seismic. Earthquakes don't shake the air. Birds are safe up there. And it's not water. They need, well, water. So the answer is sound. Sound goes through everything.
Number 2, does the medium that a wave travels through go with the wave from the source to the finish of the wave?
The answer is no. The wave is energy. It passes through the medium, but the medium ends up where it started. Watch the surfers not riding down the face of the wave. They go up, down, and right back to the start.
And number 3, which of the waves is most useful?
And the answer is light, also known as electromagnetic radiation. We haven't even scratched the surface of what light can do. But if you like TV, the internet, computers, cell phones, weather updates, microwaves, or really any part of modern society, think light.
So all waves carry energy from one place to another. They all have a source for their energy, and they travel in one of 3 ways. They need a medium to travel through, except for light, it can go through space. And humans have found out countless ways of harnessing the energy traveling in waves to make the modern world possible. And this is the wondrous world of waves.